before you show that video, I'll let you get it queued up, but let me have a few words with these fine teachers. First of all, folks, I really salute you. Think about the diversity of the teachers that are in this workshop today. That is exactly why I love teaching and learning with geotechnologies. It is because you've got math teachers, you've got history teachers, you've got geography, environmental studies, language arts. I've had art teachers in these workshops before. So geotechnologies brings together a great diversity of levels and also subjects. So I salute you because you're not the kind of teachers that just want to do the same old thing year after year, right? You want to have the students actually engaging in inquiry, in problem solving, in looking at real world issues, and looking at things in a cross-disciplinary mode. So you've got a little bit of math and a little bit of environmental studies and a little bit of geography in a certain lesson. That's exactly what you can do with these tools and these methods. So I salute you all. I also think we need more university professors like Dr. M. That are really passionate about let's think about education not just for my own students, but let's think about lifelong learning from K to gray. So we need more professors like Dr. M. We need more principals like Dr. O. She's wonderful, and I really salute you, Dr. Cynthia, for gathering these fine people. And also we've got Maria and others in the community that are willing to stand alongside you and mentor you as you move through this journey into geotechnologies. Now I say journey because, how's the audio quality on your end? This is like 1,000 kilometers between us. Is it okay?
Yeah.
All right. I'm up in Denver right now. Yeah, a little bit cooler than where you are in terms of temperature, but just almost on the same line of longitude as you're thinking spatially. Just pretty much due north of you on 105th meridian. Anyway, but the point is that as Dr. Cynthia said, geotechnologies is all around us, right? So let's say you use Uber. Who's used an Uber? Okay. Uber would not be possible without geotechnologies, right? Knowing exactly where you are and where all the potential drivers are, that would not be possible without geotechnologies. Who's ever used a web map to figure out where the nearest coffee shop is? Let's say you go on work travel, or you go on vacation or something like that. You want to find out where a coffee shop or a cool place to visit, right? You used a web map, even on your phone, to figure out where that stuff is, right? So that's geotechnologies in action. All of those addresses are geocoded, and so you can figure out where things are. The electric lights in your room, right? The electric company is using GIS to manage their lines, right? So where does the power come from? Where does it need to be distributed? On a super hot day in El Paso, where is the electric load heaviest? All of that is managed with a GIS. They're not doing that with a bunch of paper maps like they were in the old days, okay? Lastly, what you had for breakfast this morning. Maybe Dr. O is feeding you there. Anyway, what you're eating, right? The food distribution in the world is managed by geotechnologies, right? Where the orange growers are growing oranges and how they manage their harvest and how they get that product to their markets. That is all managed with geotechnologies. So I just wanted to build on what Dr. Cynthia was saying in terms of how it is all around us. It's, in my way of thinking, folks, it's kind of like an elevator. You just get in and it works. You don't really think about what's going on behind the scenes. That's the way it is with these geotechnologies, okay? Lastly, as Dr. M is queuing up that video, which I hope won't torture you folks. It's only 3 minutes long, okay? Anyway, but think about this. Put on your teacher hats here. One of the ways that I like to introduce this to students is as follows. They're already using cloud-based tools. They may not think about it, but they are. So, for example, especially those of you that are teaching upper secondary or even lower secondary, you ask the students, hey, you have some documents that are local to your computer, right? But you also have documents where? Where do you have these other documents that are online? Where do you put them?
In the cloud.
Okay, where in the cloud? What kind of tools are you using?
Office, yeah. OneDrive, Office 365.
I love you folks, exactly. Those are operating on a whole set of servers, right? You don't really care where they are as long as it works and you can access your documents, your spreadsheets and your word process documents, correct? Now, why do you do that? Why do you not have everything local like you did 10 years ago? Why do you have stuff up there?
Storage space.
Devices crash.
Storage, okay. A lot of these tools have virtually unlimited storage anymore. You might pay a little bit, like in Dropbox, I pay like $99 to get several terabytes a year, and that's worth it to me. But others, you don't even pay anything, right? So what's another advantage to having stuff up there?
Different devices can access it.
Accessibility.
You folks are great, exactly. You can access it from anywhere. You can share and collaborate with colleagues, right? You can both work on the same document. For example, this one that you're looking at here. Are you guys seeing the outline?
Yes.
Yes.
Cool. So that's what Cynthia and Dr. M and I worked on over the past years. No, just kidding, just a few months. But we worked on this document, right? So that's what you do as well in your own workplace, right? You've got a lesson that you're working on with another teacher, let's say, or you're writing an article for a journal or something like that, and you put it up there so that your collaborators can all contribute. So you're not emailing it back and forth all the time with, oh, do you have the latest version type of thing. And so you've got documents up in the cloud. You also have music, right? You don't have all the music on your local device anymore. So where do you have your music?
Streaming services.
Everywhere. Spotify. Yeah.
I just asked you. I used to.
Absolutely. Spotify, Pandora, Amazon Music, Apple Music, iTunes, etc. Right? These are all cloud-based services. Now, the reason why I'm going through this with you is because I want you to think about how you might actually talk about this with students. And the music one is a big one, right? They all have tons of music everywhere. So if I want to access my ABBA's greatest hits, okay, from wherever I am, I'm going to put it up in the cloud. Excellent. Now, lastly, GIS. If you were in a workshop with Dr. M, Dr. O, and I 10, 15, even 5 years ago, it would have been vastly different from right now, right? You all brought your own devices. We're going to access GIS, Geographic Information Systems, in the cloud, right? In the past, we would have had to go to Dr. Cynthia's school, load software on her computers, and be in a dedicated lab with high-end computers. So the good news for you and I as instructors is that you don't have to do that anymore. As long as you've got a web browser and you've got an internet connection, you're good to go. Now, for those of you that, we've got a third grade teacher in there. I visited a third grade classroom not too long ago, and the teacher was making a very effective use of what we're going to go through today and tomorrow with one computer and one projector, okay? And the students at that school did not have their own tablets or laptops, okay? So, but the teacher was teaching about, this was in California, it was about ecoregions versus where people live. So do people live in deserts? Do people live in mountains generally? So the teacher was making a very good use of, engagement with the students, but there was just one computer and one projector. That's it. So it can work in a wide variety of settings is what I'm getting at, okay? Excellent. So let me lay this last thing on you. It's even more important that GIS is in the cloud outside of education, because when you think about all of the things that GIS is being used for, transportation, bus systems in El Paso, ecoregions, biodiversity laws, looking at coastal erosion, the spread of diseases, etc. People want to collaborate on solving these problems, right? So having the data and the tools up in this cloud-based environment is really huge, because as you know, and again, put your teacher hat on, what you can get the students to think about is that these issues do not stop at disciplinary borders, right? It's not just math, it's not just science, it's not just geography. They span disciplines. They also span borders, physical borders or political borders, right? So coastal erosion is not just a UK problem, it's a USA problem, it's a China problem, it's a Japan problem, right? Coastal erosion. Soil loss, urbanization, poverty, disease, energy. These are all global issues that increasingly affect our everyday lives. And that's why we want to have these things up in the cloud. Good, awesome, good on you, mate. I taught in Australia last year. Good on you, mate. Okay, so I will let it go at that and let Dr. M show this short video that's just a few minutes to kind of get you excited about, okay, why get excited about web maps and GIS?
Thanks for the advertiser, Dr. K. I think you've given these folks quite a few tips.
No worries, no worries. I hope that was all understandable. We are going to, while you guys are waiting for that video to come up, go ahead and fire up some sort of a web browser. Okay, you probably have one going on your device, but we're going to go to the location that the outline is, and I'm sure that Dr. M or Dr. O can direct you to the outline because we're going to click on a couple links here in a minute.
Okay, so yeah, let's just wait for them to complete the survey.
Oh, they're filling out the survey. Ah, okay, very good. Folks, I hope that wasn't too much torture. Nobody's running from the room screaming with their fingers in their ears, so that's a good sign. Let us do the following. You know where the link for today's workshop is, correct? As you fire that link up, it's basically the document for today's workshop. I'm hearing some audio interruptions. The outline for today's workshop. As we do that, I'd like you to just review our goals. What we want to do, folks, is we want to develop some knowledge and skills, teaching skills, and also the confidence that, yeah, if you get out of here on Saturday afternoon and you are intrigued by one or more of the things that we've shared, then you can say, hey, I can actually do this in the classroom. That's our goal. We want you to embrace at least some of these things that we're going to go through. Now, Geo Technologies is a journey, not like the 80s band Journey, okay? I mean a journey. Like, you're not going to learn chemistry in 2 days. You're not going to learn biology in 2 days, right? You're not going to learn mathematics in 2 days. It is a lifelong endeavor. So don't get frustrated that, ooh, I don't know exactly how to do everything that Joseph and Cynthia and Dr. M shared, but I have enough confidence and I know I can go back to these resources and I can actually give it a try. Go to the workshop. Start with the workshop outline, and I want to have you scroll down to the agenda, okay? So start with number 9 there. We've just looked at a couple of videos, well, actually one video. I invite you at some point in your own spare time to look at some of those other videos that we have linked there, because I think it will be valuable to you at some point. They're all just a few minutes long, and so they're very doable. So what we're going to go through today and tomorrow are these short, mini geotechnology immersion lessons, okay? Again, don't feel like you have to encompass all of them on Monday when you're in the classroom, well, or in August when you go back to the classroom if you're on summer break. But the point is that take some of those pieces and try them out. Now, you and I have been in workshops for years and years, right? And we all know that if you don't actually try something soon, within a few weeks, you're going to say, what were those people doing way back in June? I don't remember now, okay? So I encourage you to try at least one of these things sometime in the next few days after the workshop ends. Just a little tidbit of it. Okay, super. So if you go down to number 9 there, go ahead and fire up that 2018 World Cup stadiums. Now that is called a story map. A story map is a multimedia web mapping application. Now that's a lot of words, I realize. A multimedia web mapping application. Now, but we bring it up because of 2 reasons. Number 1, it's an illustration of audio, video, satellite imagery, and photographs. And number 2, it's an illustration of, hey, I can teach about current events using geotechnologies, whether it's last week's volcanic eruption in either Hawaii or Honduras, or the World Cup, or some other event that's happening around the world, or in your local community. So you can actually teach about current events and bring up things. These things that you bring up, this could be a 5-minute introductory lesson. in your Monday morning class, right? Hey, here's a world event that's happening right now, in this case, World Cup. So you might get some students that are really interested in sports, and they're interested in looking at these different stadiums. Where are these stadiums? What kind of land use are they in their local community? So let's look at this first one. You get some text in there. Hopefully you're all pulling this up. Where did I pull this up from? I pulled this up from that very first link. Oh, now I'm hearing some audio. Very good. That very.
We can hear you.
Oh, so cool.
I'm gonna mute though, okay?
Yeah, no worries. So in that 8 o'clock to 8:30 arrival and registration, we've all done that. Good, good, good. So number 9, this is short activities using 5 web maps, and I clicked on the 2018 World Cup stadiums. Okay, that's where we are right now. You don't really need to look at my screen because you've hopefully got it on yours. So in each one of these, this is called a map tour. Now tomorrow morning, we're actually going to, and this is another reason why we wanted to show this, we're actually going to have you build one of these. So the nice thing is that these tools, these data sets are online, and they're great to use, and there's no shortage of things that you can use. But you can also, and I think more importantly even, your students can actually build their own. Okay, more about that tomorrow when we build a story map. So let's look at a couple of these stadiums. Feel free to browse around. You don't need to wait for me to guide you because they're fairly intuitive. They're fairly self-explanatory. So if I look at Yekaterinburg Stadium, you know, where is that? Well, it looks like it's in Russia somewhere. If I zoom out to the neighborhood, I can kind of see that this is like a circular. So those of you that are teaching 3rd grade, right, have the students indicate what's the shape of these. They're not all the same shape, right? Some are ovals, some are rectangles, some are squares. Have them verbalize the spatial pattern of the actual stadium, the shape of the stadium. And also, for those of you that are teaching maybe middle school and high school, have the students think about the land use around the stadium, right? They're not sitting in some residential area, right? These look like apartment buildings right around this particular stadium. A lot of these stadiums are near a busy street, like this one. So get the students thinking about, okay, let's say you were going to build one of these stadiums. Where are you going to put it? Are you going to put it in the middle of some neighborhood in El Paso? First of all, there's zoning. You can't just plop these anywhere. And secondly, there are certain kinds of establishments that need access to bus lines, rail lines, right? Maybe a major airport nearby, maybe a busy street, right? So people can actually get to the stadium, right, folks? So have them think about, okay, what are other things that are like this? And look at this one. Some of them have domes. Get your students to think about which have domes and which don't have domes. This particular one looks like it's on a major, what is it, an ocean, a body of water of some sort. So if I zoom out, right, scale matters. If I zoom out, okay, so where is this? This is on the edge of the Black Sea. Some of your students may do some research, and you can ask them, hey, what event that happened in the last 10 years was actually in this same location? Now it indicates it right there. It was the 2014 Winter Olympics. So get them thinking about where is this in relation to these other stadiums that are on this map. And if I zoom out, I can actually see the distribution of the particular stadiums that are on this particular story map. So again, a simple example, but I hope an effective one that gets you thinking about, oh, I can build these things, and also I can look at spatial patterns. So let's just continue with a couple more questions that you might ask. Why aren't there any stadiums way over here where I'm pointing? I don't know if you can see my mouse. Way over in Siberia, or in the western part of maybe over here up by the Arctic Ocean, or the eastern part of Russia, way over here by the Kamchatka Peninsula. Why aren't there any stadiums over there? So maybe think about using this in conjunction with a web map that indicates population distribution, or even a wall map that you might have looking at major cities, or a map in their textbook, right, that shows where the major cities are in Russia. There aren't any stadiums over in this far eastern part of Russia because what's the population over there? Maybe 500,000 people in the size of Texas, California, New Mexico, Arizona combined. I mean, the population density is very low over there. There's reasons for it, so you could then pull up a map of ecoregions and climate and explain why have your students explain why are there so few people up in those frosty areas. Okay, so that is just a story map. It is a map tour story map. And now I'd like to have you folks go back to the outline for today. Does anybody have any questions as we go through the next one here? No questions?
No questions.
Is everybody asleep? Is that the most boring map of all time? I think it's pretty cool. Hopefully you and some of your students will as well, because it's, again, showing patterns, relationships, trends. We're looking at scale. We're looking at what is the satellite image, all kinds of things you could include that I'm kind of skipping over. But you being the good teachers that you are, you could design, you could think of other questions that we did not pose while we were going through there. Okay, very cool. Let's go to the mapping Starbucks, because this is, and if you go to the mapping Starbucks, you actually see a short lesson that I wrote on this particular web map first. So as we go through the next few days, you might wonder, hey, how do I, come up with some questions if I'm really starting off with a map? I need some advice on what kinds of questions to ask. Well, for some of these maps and data sets that we're going to be analyzing, there are some lessons as we'll go through here in the next few days. This being a short lesson that I wrote that gets you to think about some questions to pose as you look at the distribution of Starbucks. Now, I know that you and I are very passionate about the environment, watersheds, natural hazards, and so on, right? But some of your students won't have any real connection with the environment, right? You read Richard Louve's Last Child in the Woods, and as you know from being the teachers that you are, a lot of students have zero connection. They've never gone hiking, they've never really gotten into a riparian zone, etc. Right? They have really no connection. So that's going to take a while to develop. So you might go into a map of world biomes, and they could care less about world biomes, okay? But if you start with something that they are experiencing daily, namely businesses in their local community. So an introductory activity to this particular map and lesson could be, okay, think about the distribution of different businesses in our El Paso Metroplex, right? Paseo del Norte. Think about where florists are, or convenience stores, or car washes, or antique stores, etc. Right? Some of them are clustered, some of them are dispersed, but they all have a certain spatial pattern. Same thing with a certain kind of business. So certain businesses, right, have certain criteria where they can locate. So for example, the classic example that we used in geography for years, and I know there's a couple of human geography teachers, so you'll in particular, I think, love this. But when a community in Texas especially got 5,000 people, they got a what? They got a what when it was 5,000? What kind of business did they get? It's a chain.
Can you hear us?
Yep.
We're saying Walmart, McDonald's.
You're thinking along. Yeah, you're thinking along a good line there. It was a little higher for a Walmart, but traditionally, I mean, extending from the 1990s through the 2000s, when a community had 5,000, it got a Dairy Queen. Okay, so a Texas community with 5,000, the Dairy Queen Corporation. You might have to reload that distribution of Starbucks, but yeah. So there's my lesson. But more importantly, think about, okay, when does a community get a Home Depot? It has to be a little bit bigger, right? So certain businesses have to have a certain population before they'll locate somewhere. Yep. So think of IKEA. That has to have a major population center. So you could actually map the IKEAs. That's a separate lesson. But think about if you have 100,000, you probably won't get an IKEA. If you have 1 million people in your metro area, you might get an IKEA. So in Denver here, where I'm located, we finally got one maybe about 10 years ago. Okay, so Denver was like 2.5, 3 million people, and we finally got an IKEA. So get your students to think about, okay, what are the criteria for getting a convenience store? Well, probably just a few hundred people, right? But for a Walmart, maybe a couple tens of thousands of people, and maybe for something like a Home Depot, maybe 50,000 people, and maybe for an IKEA, 2 million people. So certain businesses have to have a certain population around. Now, this particular one looks at Starbucks, and the way this works is a couple of things to point out. This is using ArcGIS Online. This is the mapping platform that we're actually going to be spending most of our time on here in the next 7 days. Just kidding, just kidding. You're not going to be stuck here in this room for the next 7 days. Don't panic. No, it's just 2 days. Just a little bite-sized mini, what is this, a gluten-free, calorie-free introduction to GIS.
Dr.
The vegetarian.
We could,
So the map defaults to Manhattan, as you can see. And one of the things that we'll be doing in the next few days is symbolizing data differently. This particular one's called a heat map. So named because, and let me paste this URL into the chat box. So you'll have that directly. But it's so named because it's hotter, the colors are hotter or yellower where there's more concentration of something. Starbucks being one of them. This could be fire hydrants, this could be earthquakes. You can make lots of different things as a heat map. So get your students thinking about, it doesn't mean it's hot like a wildfire. It means it's more dense. There's more things located close to each other, okay? So already you're starting to get them thinking spatially by using these certain terms that you're using. So here in Manhattan, think about this. You pan and zoom a little bit, and here is a sort of a lack of Starbucks. Why is this? Well, what is this feature? What if we change the base map? If you go up to base map in the upper left, you can change it to something like OpenStreetMap. If you change it to OpenStreetMap, you'll see that, oh, it's Central Park. No wonder there's no Starbucks there. So it makes sense that there's no Starbucks there, but then pan down to someplace like Times Square and pull up maybe a ground photograph or a video that someone has taken. I've got a couple videos on my channel, for example, on Times Square, and it is super busy, right? And you can see this heat map right here at Times Square. I mean, there's a Starbucks every, well, look, there's a measure tool. Ah, so if we measured, we could measure in meters or feet, whatever. But between here and here, there's 155 meters between those two Starbucks. Here, there's, see what I'm doing? There's 236 meters between those two Starbucks. Let's say you don't want meters. Let's say you want feet. Okay. Between this one and this one, there's 345 feet. They're right across the street from each other. But now if we go over to El Paso, so in the upper right, there is a search box. So if I go to El Paso and I zoom in there, I'm going to see some, you can see the Starbucks are located using this little tiny goldish button, which of course you can change because this is, you have the capability of changing these things. We'll go into that in a minute. But you notice that there are far fewer. What about over in Juarez? There's a few. Yep. So looking at the distribution, there's a couple downtown that are really close to each other, but it's nothing like Manhattan. Okay, but there are some. Now this is a global data set, so the students could look at, oh gosh, I wonder if there's any in Tokyo. I wonder if there's any in Beijing, etc. Right? What if I go over to a place? Well, what if I pan? Right, scale matters. So I'm going to zoom out either with these pluses or minuses, or I can zoom out over to Loving County. Right? You all know about Loving County, right? It's just to the east of you. There are fewer people in Loving County than any other place in the country. It's the lowest population county. Look, there's no Starbucks. Why? Okay, so get the students thinking about that. The closest Starbucks to Loving County is over in Midland, Odessa. Okay? So certain businesses locate in certain places. And so if I zoom out again, I'm going to see all of Texas, but it's not till I zoom in. Notice how the heat map for Starbucks, as in many of the layers that we'll look at over the next few days, are scale dependent. And that's actually a good thing. So as you zoom out and go to a smaller scale, you don't actually see the data until you zoom in part because there would be so many at this scale, it would be kind of unreadable, if you know what I mean. Okay? So get them thinking about the distribution of a business like Starbucks. Why do they locate in El Paso where they do? Now I have another lesson, just as an aside, on bail bonds versus car washes. You might wonder, how do those things relate? They don't. That's the point. Bail bonds are very concentrated, right? Around where? Now, for those of you teaching elementary school, they probably won't know what bail bonds are. Hopefully they won't. You know what I mean? But let's say you use this in a high school. You get them thinking about, okay, what is a bail bond service to get people out of jail, and where do these things locate? They're near courthouses, right? They're near prisons. So they're much different in terms of their distribution than a car wash, right? A car wash gets students thinking about, where those might be located. They're probably dispersed. They're probably on busy streets, and they're not concentrated in any way. They want to be away from each other. You very seldom have the kind of phenomenon that you have with like a Burger King and a Wendy's on opposite corners. Car washes, you know, you don't go to one and then want to see other car washes around. You pretty much go to one maybe in your neighborhood. So lots of things to think about spatially with these two maps. How are you folks doing? How you doing? How you doing? Forget about it. Okay. You folks doing okay? All right, let's go to this third one here, Fiery Cross Reef. Okay, Fiery Cross Reef. So I'm clicking on the third one if there's no questions about that Starbucks map. This is all in ArcGIS Online. The reason why I want to show a couple of these web maps right here at the beginning of the workshop is to get you thinking about lots of different themes, lots of different scales, and just to get you immersed in the whole idea of thinking spatially with these web mapping tools. Okay, folks? Now, how many of you have ever taken a MOOC, a massive open online course? A MOOC. Anybody? Okay.
Trying to decide if I have a
Couple folks? Yeah. So this is a data set that I actually put together for a geointelligence MOOC through Penn State. I wanted to have the students in that MOOC, and these are truly massive. I mean, they're tens of thousands of students. I wanted to have them looking at a current event, and so I put together a couple of swipe maps. These are maps that have this squeegee effect, right? Where you've got this big vertical bar. Sometimes it's a horizontal bar, but you've got either two different dates on either side of the bar, or you've got different themes. So it could be population in Texas versus major ecoregions of Texas, or it could be land use in El Paso versus I don't know, median age of neighborhoods in El Paso. So it could be different themes, or in this case, it's different dates. So on the left side, in this case, I've got 2013, and on the right side, I've got 2014. So in 2013, as you can see, this is a coral reef. It's in the South China Sea, and notice how different it is in just about a year and a half different. Now in 2014, you see these, and have the students be map detectives. Don't you tell them everything that's going on. Have them be detectives and have them tell you what these things are. What are these things? They look like parameciums for those of you in science. They look like microscopic little cells, but they're actually ships, right? But again, get them to tell you that. Now these big long strings on these things are they're taking sand and grinding up coral. I mean, think about the environmental implications here, and they're dumping it on the land. So they're building an island. They're building an island and a harbor. As you can see, it's rectangular with a mouth going out to the ocean. Now, why are they doing that? This is, again, I think a good point about all these geotechnology tools. So tomorrow, for example, we're going to be looking at earthquakes, plate tectonics, volcanoes, earthquakes, and so on, okay? You might say, hey, Cynthia, Joseph, Dr. M, this isn't all the students need to know about plate tectonics. And we'll say, yes, you're exactly right. What these mapping tools are supplements. They are ways of getting your students interested and thinking about your goals in your particular educational lesson, whether it's on the Dust Bowl or whether it's about population change or whether it's about mathematics or whatever. Okay, so in this case, what I want the students to do is think about change over time, and also in this particular example, the implications of this. So this is part of a lesson on the geopolitical ramifications of China building these cities and these military installations in the South China Sea. So if this is part of your unit on, as we built this map in conjunction with the unit on, why is China asserting itself in the South China Sea? What other countries might be upset about that, namely Vietnam and the Philippines? This is a long way from the Chinese mainland. And so how do we know that? Well, if we zoom out, we can start to see other things in there. Okay, we can see the different scale. Now, I don't have the base map set up, but if we go out to ArcGIS Online and look at the South China Sea and the Spratly Islands, that's where these are, okay? So there are environmental implications, right? We talked about the coral reefs, now being highly damaged by all this construction going on. I mean, imagine building a military base in the Great Barrier Reef in Australia, right? Just think of the environmental implications. Same thing here. It's not as big as the Great Barrier Reef.
Dr. K, we have a question.
Yeah.
Dr. K, the question is have prepared lessons for teachers?
Some of them do. That we'll go through in the next 2 days. Like the Starbucks, you've got basically 4 paragraphs from me with some leading questions. We're going to go into a whole series of what's called geo inquiries here in a bit, where you'll see that these geo inquiries are basically 20-minute lessons that you can start with those questions. You can say, after you've gone through it, you know, I really don't like those questions. I'm going to have my own questions. I'm going to design my own questions. That's perfectly fine. But yeah, most of the maps that we'll use in the next few days are actually going to be tied to lessons. The Starbucks one, again, had a short series of questions and a short lesson. This particular one about the Fiery Cross Reef, yeah, I've got that is packaged up into a lesson as well. So, but this first set of activities is kind of get you thinking about, wow, this is pretty fascinating stuff. And maybe, you know, teaching about the South China Sea is not your thing. But what I want you to think about is, hey, I can create a swipe map for different neighborhoods in El Paso. I can make a swipe map showing median age and median income. I know that there's a math teacher, at least a couple math teachers in there. So this could be a supplement for your unit on what is a mean, what is a median, what is a mode, etc. Okay, so and then how do medians transfer to a geographic area like a neighborhood? And why do we care about median age? Well, it affects the number of schools that we have to build, the number of retirement communities, you know, etc. So get them thinking about mathematical concepts with a swipe map like that. Cool. One more. Let's look at this last one here, this Sentinel-2 imagery and a story map. Another story map. And it's also another highlight of a current event. Combining several different geotechnologies. It's not just the web mapping, it's not just the story map, but the organization I work for, ESRI, we've got a business partner called Hangar, like the hangar for an airplane. And as you fire that up, you'll see that Hangar, our business partner, they're like an Uber for drones. They're like an Uber for unmanned aerial vehicles. And so what they did recently was they actually flew over Kilauea. So with this imagery, I think this is just fascinating. You've got a web map here in the upper left where you can go to different locations, but you also have this immersive 3D capability of looking at these lava flows just about 2 weeks old. So I'm going to go to number 11 because I think that was, to me, that was the one that stood out for me. Now, all of these maps that we're looking at here at the introduction to our workshop, folks, I think every one of these is so fascinating. We could spend 2 days on just these maps right here. I mean, they're just so amazing. They bring geo tears. You know what I mean? I'm getting all weepy over here in Colorado. I'm going to have to bring out my handkerchief. You know what I'm saying, folks? But this one right here, look at this property. I mean, these people are getting buried. Maybe they've got time to move these vehicles out of there. They better get these vehicles out of there soon. But where are they going to go? This road over here is completely blocked by this lava, and get students thinking about, gosh, they take down these trees, right? Their garden on their plot is getting overrun by these lava fields that are spreading, and look at all this smoke. So there's airborne particulates that are not too safe to breathe, so etc. So this is combining, again, UAVs, unmanned aerial vehicle, drone imagery with a story map. This is just a map tour story map, and we're going to build one of these tomorrow. But what a great resource to use in conjunction with, maybe you're teaching about volcanoes and earthquakes and plate tectonics and a current event all at the same time. This would be a great example to use, okay? One more thing. This is a story map. How are you folks doing? Isn't this fascinating? Oh my gosh. Again, we could spend the whole day on this. This is just, and talk about, you know, when I've shown this to students, just even my university students in the last 2 weeks, it's kind of hard to pull them away, right? It's like they're so engaged by examining these very real issues. So then I include things like, okay, if you've got a piece of property, and how much warning are you going to have, and what's your evacuation route, etc. So we can use these maps to look at, okay, well, where is this in Hawaii? Is it on the Big Island? So if you zoom out on the map, you can see that truly this is the Big Island of Hawaii, right? It's on the far eastern tip of the Big Island. And let's say you're teaching third grade. They have no idea where Hawaii is, right? Where is Hawaii? Well, I know it's in the ocean somewhere. Well, which ocean? Well, I have no idea. So let's actually zoom way out. And now let's, again, think about your elementary teachers in that room. Okay, a lot of people know, even in elementary school, that it's somewhere west of California, right? It's west of Texas. But it's actually quite a bit south as well, right? So Hawaii is, right, it's at the, have them kind of trace their mouse across, it's at about at the same latitude as just barely north of Mexico City, right? So it's pretty south, it's pretty far south, as well as being a decent amount of distance west. So it's not just west, it's quite a bit south as well. And that's why you've got all that tropical vegetation there, right? So get them thinking about different scales and where these things are actually located. Okay, very good. Just one more thing there on that note. Let's say you wanted to use this in conjunction with another map that actually is part of this whole theme. And I'm going to show you that right now. Inside ArcGIS Online, we've got, okay, hearing nothing from the community, we are going to pause, but the maps that we've been looking at are all part of this ArcGIS platform. It is a cloud-based, web-based geographic information system. Okay, so it's not something that you have to load locally. There's still desktop software around, but for education, I highly advocate using this online platform. And so that's why our whole workshop is all revolving around how do we use this platform to make our own maps, to have our students go out and gather data in the playground or in their community and map it. How do we look at things from local to global scale? Yep, so yeah, we have a whole boatload of stuff, not all of which we'll be able to get through in the next 2 days. But again, we've got more things in that Dropbox that we'll be going through in the next 2 days so that you know exactly what's in there that you can actually access. Last thing that I wanted to do with you all is think about a couple of things. Here's a couple of slides. Don't worry, I'm not going to go through every single one of these, but just as my segment closes right here, it really, GIS, Geographic Information System, is STEAM, right? That's what you all are about. Science, technology, engineering, arts, mathematics, social studies as well, and active learning. So that's what I wanted to just briefly go over here. First of all, I just want to lay this out before you. Not everyone in society needs to be a geographer or a geographic information system specialist, but every decision maker needs to think spatially and critically. And that's what you and I are all about right in the classroom. We want to have students be critical thinkers for tomorrow. And I don't think that Geo Technologies is the only tool that helps them do that, but I think it's one of the key tools that allows them to do that. Now, you and I know, are you seeing these slides, folks? As educators, we have to choose the most appropriate tools for the job, right, folks? You can't use every single wonderful tool that's out there. And there is a growing body of knowledge out there that indicates that thinking critically and spatially with maps actually helps students make more critical thinking points or decisions along their educational pathway. It doesn't necessarily lead them all to be STEM career people, but let's say they go into business, let's say they go into health or some other field. Well, they're going to be thinking spatially, they're going to be asking the where question, and they're also going to be critical of data. Don't just accept it because it's online, don't just accept it because it's a map. You know, you really be critical of data, especially in our data saturated world, our big data world, right, folks? And so I'm not saying convert every single thing that you're doing in the classroom to geographic information systems. No, choose the most appropriate tool for the job. If you're teaching about population change, for example, I was working with a teacher, a high school teacher. He had a lesson where he basically had the students read an article about students in a university town and how the student core has really spread over the last 30 years to not just that neighborhood next to the university, but all throughout the town. And then he gave them a set of tables, and they had to color with colored pencil on these paper sheets, indicating by census tract where the students actually lived. They did that for about 2 days, and then the end of the week, they wrote a report on what they discovered. That was the perfect lesson to incorporate geotechnology because of a couple reasons. One, the students kind of got to the report and they really didn't refer to their maps that much. It was sort of, okay, we'll make these maps because the teacher told me to, and now I'm going to write my report and I'm going to refer to my article, but I'm not going to really refer to the maps. Once the teacher incorporated a GIS, so we had them look at population change from 1970 to 2010 for the census years. Once he had them do that, the students, what we found is that the students actually referred to their maps a lot more. They thought spatially a lot more. Plus, the teacher could accomplish a lot more analysis that week rather than having the students spend 2 class periods basically coloring. Okay, not that coloring is bad, but you know what I mean? So you got to think about what units would be appropriate to do this. Again, the 5 of us here on the instructional team, we're not saying, yeah, everything you need to convert to geotechnologies. No, no. You have to, as the wise educators that you are, choose the most appropriate tool for the job. Now, I used to work at the U.S. Geological Survey for many, many decades, well, 17 years. From the Cretaceous to the Holocene, a long time. Nah, just kidding. Not that old. But the point is that we had a map at the USGS, and you could still get it. You can even get it in PDF form like this. Tsunami generating earthquakes. Kind of an interesting map, kind of busy. It's nice that it's sort of in 3D. But a map like this is a good illustration for what we're all about in these next 2 days. I want to find out what tsunamis have been happening in the last 10 years. So going back maybe to the 2011 Japan tsunami, I want to look at, are they increasing in severity? Are they decreasing? Where are they located? You can't do that with this paper map or even the PDF version of the paper map. You can't ask questions of it really effectively. You can use it. And so another map that I loved is this dynamic planet map. This dynamic planet, so different and so new. You didn't think I'd sing, but I just want to make sure you folks are awake. Anyway, the point is, there's a map called This Dynamic Planet. You can lay it out on a big table in your classroom, and I love this map because it's got earthquakes, volcanoes, and plate boundaries on it. And what educator couldn't take that map and teach with it, right? You don't necessarily need a lesson with it, you just teach with it. But that map has limitations. Number one, it's really big. So you've got to have some table space. Number two, it was produced in about 1995. So you can't say, well, give me all of the earthquakes in the last year, or what about those that ones that are associated with Kilauea in the last month? You can't change the scale. You can't add data. You can't say, what are all the earthquakes in the last 100 years that have been within, I don't know, 100 kilometers or 100 miles of El Paso? Have there been any? You can't do that with that paper map. So I'm saying to you all that paper maps are still useful. They have their place, but these digital maps have a lot more utility. Also, as we talked about earlier, GIS, Geographic Information Systems, is at this major turning point. It is a cloud-based platform, which has huge advantages now for us as educators. And also things that students are actually going to encounter in the workplace. You don't have to install software. You don't have to battle with your IT, sorry, did I say battle? Work with your IT staff at your school, right? Sometimes it's good, sometimes it's bad, right? But you know, you don't have to you don't have to deal with all that. You don't have to install things. You've got Chromebooks, great. You've got some iPads, great. You've got some laptops, great. All good. You can use the platform with those different devices. Also, what we're talking about, folks, is that this geographic information system stuff is not just some little niche technology that's, used by just a few people. It's actually tied to some of the fundamental things happening in IT and society, like big data, like the Internet of Things. It also provides you and I with an opportunity to talk to students about location privacy. When you have an app and it says, hey, share your location, do you always say yes? Why does the calculator app need to know my location? I'm going to say no. No, I don't want to share my location. So what are the implications with sharing your location for the apps that you use on your phone? I mean, these are real, everyday kinds of conversations that you can have with students. And also, because this platform is contributed to, it's a crowdsourced platform, anybody can make a map. So if anybody can make a map, that means your 8th grade students have maps on this platform. They may be really good maps. They may be maps that have very little documentation as far as who made them and why they made them. So you've got, again, a great opportunity to teach your students about data quality. Don't just accept it because it's online, right? Third thing, and I'll just leave it at this, but there's lots more we could talk about. You can also think about those story maps. If you're incorporating photographs, for example, in those story maps, hey, can I use any photograph that's online in my story map? So what about copyright and permissions? Great things to talk about as a teacher, right? Do I want to use photos from Bob's Photos Inc. in my story map? Probably not. I don't want a call from Bob someday that says, hey, I noticed you using my photographs in your story map. I don't recall giving you permission to do that, right? You want to use photos from your own camera, your own phone, or photos that are in the public domain. Photos on usgs.gov, on census.gov, on Wikipedia with a Creative Commons license. You know, all that kind of thing you can talk about with the students about permissions. So touching on what I mentioned earlier, GIS really breaks down barriers. GIS is what I call a transformational technology. So think about motion pictures. When motion pictures first came out, what were they filming? What were they filming, folks? Like, I'm talking about like 1910, were they very, very first motion pictures? Anyone? Think about how they were telling stories back then, right at the advent of motion pictures. So before mass media, right, how did you find out, how did you engage in someone telling a story? Stage plays, right? You went to a playhouse and there were probably was a live orchestra there, and that's what they originally started filming. Hey, let's film these stage plays, and then more people can actually see the play that actually didn't go there face to face. So we'll film stage plays. So then, after a couple years, people said, you know what? We can go outside. We can go elsewhere and film. So then motion pictures became its own industry, its own art form, its own major segment of society, right? So it became a transformational technology. It wasn't just doing what we did before and just filming it. So this, in the same way, make the leap with me for a minute about GIS. It's not just making maps in digital form, it's asking new questions. And that's so hard in education, right? To get students to really ask those deep and rich questions. Yeah. All right, we better move on. I want to just have you think about this. Why teach with GIS? Here is a 3D scene of earthquakes that I extruded the earthquake into a cylinder, so you can actually pan around on the map in 3D and have the students think about, why are there so many more earthquakes in California and Alaska than in Texas? Well, you've also got the ability in this 2D map to look at temporal data, the last 7 days. I want to look at the last 7 days of earthquakes. I want to look at the last month of crime in El Paso. I want to look at the last 2 years of the Zika virus around the world. You know, those are the kinds of things. You're looking at things spatially, but temporally as well. Just a few more things to share with you. Scale matters in looking at these live web maps. So here is the same platform we looked at a couple of minutes ago, ArcGIS Online. So here I've got, historical tornadoes from NOAA, National Oceanic and Atmospheric Administration. At this scale, it doesn't look like there's any out west, Colorado where I am, like West Texas where you are. But if you zoom in on those maps, you actually start seeing the Fujita 2s and 3s, not as severe, but they still exist. So scale actually matters. It gets students thinking about data and the patterns. Another cool thing about that particular map and lesson is that you can look at data temporally. So you can look at January, February, March, April, and how the tornadoes sort of spread from the Gulf Coast up to North Dakota and Montana and then back down. So if that's a piece of maybe your lesson on weather and climate, it could be a 10-minute lesson. It could be more than that. Another thing that we're going to be doing here in the next 2 days, you're going to be mapping your own data. So let's say you got a spreadsheet. This particular one, my colleague had some whale data, okay, off of Costa Rica. So she has latitude and longitudes for whale sightings, as you can see there. The captain, the guide, the company, etc. So they have a latitude and longitude, and as I said in that video that you had to suffer through a while ago, easy to do, easy to map a spreadsheet. All you need is a city-state combination, or a city-country, or a street address, or a latitude-longitude, and you've got your data mapped. You're gonna go out with your GPS units later today, I believe, and you're gonna be able to map that stuff. Okay, very cool. Now, folks, just a little realism injection here. I know how difficult it is to teach with technology. It's not an easy thing, and myself, your other fine people in the room, Dr. O, Dr. M, Maria, Karen, others, we're all going to say, no, it's not just a click here and it's all easy and simple, okay? There are some challenges. It's easier, to be honest, to teach with, here's a worksheet, class, right? Here's a worksheet, fill out this worksheet. And you're not using any web-based, cloud-based, multi-dimensional, multi-temporal tool like a geographic information system. It's frankly easier to not use it. But I don't think the students are well served that way. I think what again, why I salute you being in this workshop, you want to actually do things that are hard, right? If you wanted it easy, you wouldn't be here spending your valuable time in this workshop. So what happens when the NOAA tornado service is down and you want to teach with that tornado map that I just showed? What do? What's your plan B? So we're going to talk about those real challenges. How do I fit this into my mathematics or my third grade social studies or my middle school environmental science course? How do I fit it in there? So that's the kind of stuff that we want to talk with you about. It's not just, here's this boatload of maps and technologies, and you go forth and do it, and live long and prosper. No, it's how do we engage in that conversation? So we've all taught with these technologies, and so we know that the challenges are real, folks. But again, I think they're worth doing. I really think, because of these reasons and more, that it is completely worth your time to dip a toe into the waters of geotechnologies. Now, let me just say a couple things in closing. Number one, the U.S. Department of Labor back in 2004 said there are three key hot fields for the 21st century: nanotechnologies, N-A-N-O, nanotechnologies, biotechnologies, okay, biotechnologies, and geotechnologies. So the U.S. Department of Labor is confirming that geotechnologies are here to stay. They're not going to go away. We will always ask the where question in society. And because we're asking the where question, we're going to use these geotechnologies, okay? So you can read these advantages of using GIS in instruction as well as I can, but they incorporate these forces that we'll embed into a couple of lessons here: citizen science, telling stories. We're going to use some story maps tomorrow, and so on, okay? So lots of topics you can teach with GIS, including these and beyond. So it's great that we have a diversity of teachers in the room. And it is all about the inquiry process. We're going to ask questions, we're going to acquire some data, we're going to explore, we're going to act on it, and then we're going to make decisions based on that, okay? So questions, comments, issues, complaints? How's everybody doing? Thanks for hanging in there, folks. I hope that was a good introduction for you. And once again, I salute you for being here, and I'm going to turn it over to my wonderful colleagues. And I'm going to be back with you in a bit for a couple of lessons here down the road. But thanks, folks.
Thank you.
Thank you, Dr. K.
No, you, ustedes.